Video Lecture 4.4, Midlatitude Cyclonic Systems. And this is extremely important for understanding Indiana weather. We are heavily influenced by mid-latitude cyclonic systems. So as their name implies, they are low-pressure areas. One of the key things about these cyclonic systems is they migrate. So they move from place to place, which is very important for understanding changing weather and being able to predict what weather is going to be coming into an area. As the name implies, they're low-pressure areas, so they're converging rising air, lower pressure, but they also spiral inward and counterclockwise. Key to understanding the migratory path of these mid-latitude cyclonic systems is the fact they migrate and they ride along the location of the polar front. We've talked about beforehand the polar front and its location in a previous video lecture. Here's the map that showcases the migratory paths of these mid-latitude cyclonic systems. Of course, we see the arrows, for the most part, going from the west and from the south to the east and to the northeast. That makes sense because of the predominant westerlies that influence this area. One of the things that you notice, there's different patterns. There's a winter pattern. That winter pattern, the mid-latitude cyclonic systems move further south, and that makes sense because the polar front also moves further south. However, during the summer, the pattern moves up to the north, in which the mid-latitude cyclonic systems oftentimes come through the Great Plains, Minnesota, Wisconsin, and so forth. And so one of the things we see is mid-latitude cyclonic systems in the polar front are really big part of springtime in Indiana, which also relates to severe weather in Indiana, oftentimes during the springtime as well. Above the polar front is the polar jet stream. The key to understanding the polar jet stream is that it steers mid-latitude cyclonic systems. So essentially is like the steering wheel. It drives the direction that the mid-latitude cyclonic systems are going. An important thing to note about the polar jet stream is the fact that it meanders. And this meanders, as we'll show here in a minute, is very important for understanding week-to-week changes in weather. This meander is called the raspy wave. At the top, near the tropopause, you'll notice there's gaps in these various cells. And that gap we showcase right here with this blue star, that's the location of the polar jet stream. There's also another jet stream in this gap here, that's the subtropical jet stream. But that doesn't influence us as much here in Indiana. So we think about us here over in the mid-latitudes, up in the northern hemisphere, we're influenced by the polar jet stream. And so polar jet stream plays a critical role in the location of the polar front, but also the location of the direction that these mid-latitude cyclonic systems are moving. Here's another way to visualize the location and the general meandering of the polar and subtropical jet streams. To help showcase the role of the jet stream and its location and its influence on temperature, we can see in the image on the left the location of the jet stream, how it dips down, keep in mind that it meanders, and the influence it had on temperatures over on the right-hand map. And so they're from the same exact moment in time. And this is why the jet stream is so important. So when the jet stream meanders and dips like it is right here, we're going to have in Indiana much cooler temperatures than we would in the next image as the jet stream moves further north. And so predominantly over Indiana, we had a couple of really intense summers there in 2011 and 2012 with very warm temperatures. And that was because the jet stream stayed for a good amount of time well north of Indiana. As the name implies, mid-latitude cyclonic systems are found roughly between 30 and 60 degrees north and south latitude, so they significantly affect our weather in Indiana. Because these migrate but also have a life cycle, they last about 3 to 10 days, and I'll explain that 3 to 10 days in that life cycle in the next video lecture. They're very crucial for predicting weather and weather forecasting. So mid-latitude cyclonic systems are very useful for our weather forecasters being able to predict what's going to happen tomorrow and going forward. Another key characteristic is that mid-latitude cyclonic systems are connected with warm and cold fronts, those that I mentioned there in video lecture 4.3. Because of this, they're also known as a frontal cyclone.